All right, today we're going to talk about inequalities in two triangles. Inequalities in two triangles. Specifically, we're going to talk about the Hinge theorem. And what the Hinge theorem says is that if two sides of one triangle are congruent, here's your symbol for congruent. If two sides of one triangle are congruent to two sides of another triangle, then the side opposite the larger included angle is longer than the side opposite the other Hinge theorem. If two sides of one triangle are congruent to two sides of another triangle, then the side opposite the larger included angle is longer than the side opposite the other included angle. Now, this is going to make a lot more sense when you see the pictures than it does reading the words. Okay? What it says is that if you've got, let's say you got a triangle, and this triangle is ABC, and side AB is congruent to side AC, and the included angle is 43 degrees. And then you've got another triangle. And this triangle is FEG. And FE is congruent to FG. And then angle F is 30 degrees. So what you've got here is two sides of a triangle congruent to two sides of another triangle. Angle A is the included angle on the left, and angle F is the included angle on the right. What the rule says is that side BC is going to be greater than or longer than side FG. And that should make sense to you. right? If this angle on the left opens up 43 degrees, it's going to create a side length that is longer than an angle that opens up 30 degrees. Does that make sense to everybody? It's like a door hinge, right? If one door is opened up a little bit and one door is opened up more, the door that has the larger angle is going to be opened up more. All right? This can also be written as FG is less than BC. All right? No, not FG. Where did I get FG from? I don't mean FG there, guys. Yeah, sorry about that. EG. All right, BC is going to be greater than EG. The other way to say it is that EG is going to be less than BC. Now, the converse of that statement is also true. Okay? So let's say that you're given this triangle here. We'll call it MNO. And then a triangle next to it. We'll call it QRT. And now let's make MO congruent to QR and NO congruent to RT. Let's make side MN 10. And let's make side QT 14. Now, what we can do is we can use these side lengths to compare angle O to angle R. All right? If we got to compare angle O to angle R, so angle O, how does it compare to angle R? Is it going to be smaller or larger? Is it going to be less than or greater than? It's going to be less than. Very good. All right. Since angle O is the included angle and it's opposite the shorter side, it's going to be less than angle R. All right. Angle O is opposite of 10, and angle R is opposite of a 14. So angle O is going to be less than angle R. Another way to say it is that angle R is greater than angle O. All right, can y'all handle that? Take that as a yes. Handle that, right? All right, then. In the second part of your assignment today, you are going to be asked to find the possible range of values for x. Find the possible range of values for x. And let's say you're given this picture. And this triangle is JEGH. So JEGH and H. Now we've got side JH is congruent to side HG. We've got angle EHG that's 65 degrees. And we've got angle JHE that is 6x plus 15. Side JE is 11 and EG is 9. Here's what we got going on in this picture. We got a side of a triangle on the left congruent to a side of a triangle on the right. Both triangles share side EH. All right, so that gives us two sides of one triangle congruent to two sides of another triangle. They both share this middle side, EH. So now, when you're finding a possible range of values for x, we did this yesterday, we got to write a compound inequality. The first thing we got to do is we got to compare these angle measures to each other. All right, this 65 is across from a 9. The 6x plus 15 is across from an 11. So the 65 is going to be smaller, isn't it? Okay, the 65 degree angle is going to be smaller than the 6x plus 15 angle. So we have to write a compound inequality. And this compound inequality is going to say that 65 has got to be less than 6x plus 15. Now, since we're looking for a range of values, we need an upper limit. All right. If the 65 is less than the 6x plus 15, then the 6x plus 15 has to be less than something. The 6x plus 15 has to be less than 180. That's because the 6x plus 15 is one angle in a triangle. And since the three angles in a triangle have to sum 180, one of the angles or all of the angles have to be less than 180. So this one in particular, this 6x plus 15 has got to be less than 180. That is your setup. Okay? So we subtract 15 from each side. And not only do you subtract, all right, you subtract 15 from the middle, from the right side, and from the left side. So 65 minus 15, that's 50, is less than 6x, which is going to be less than 180 minus 15 is 165. And then you're going to take everything and you're going to divide it by 6. So divide the middle by 6, divide the left by 6, and divide the right by 6. So 50 divided by 6, that's 8.3. So we get 8.3 is less than x, which is less than 27.5. That is how you find your range of values using that Hinge theorem when you got two triangles with two congruent sides. The second example that you're going to need to see is when you're asked to find a range of values for the sides. All right, so now we got this bow tie situation here. And we've got this side over here on the left, congruent to this side on the right. We've got this side here that's 50 and this side that's 50. A 68-degree angle and a 55-degree angle. And then a side that's 47 and a side that's 5x plus 2. So here we are again. We've got one tick mark and a side that's 50 on the left. We got one tick mark and a side that's 50 in the triangle on the right. So you've got two triangles with two congruent sides. We've got an angle that's got a 47 across from it. And we've got a smaller angle that has a 5x plus 2 across from it. So since the 5x plus 2 is across from the smaller angle, okay, then our equation is going to look like this. Our 5x plus 2 is going to be less than 47. All right, we're comparing these two sides. Comparing this 47 to this 5x plus 2. So since the 5x plus 2 is across from a smaller angle, it's going to be less than the 47. But now we're finding the range of values. So the 47 has to be less than something. All right? 5x plus 2 is less than the 47. I'm sorry. Since the 5x plus 2 is less than the 47, the 5x plus 2 has to be greater than something. It's the side of a triangle. All right, so it's got to be greater than 0. So that is your setup now. All right. When you set the lower limits of this thing, you have to set it the side to be greater than 0. So we're going to subtract 2 from the middle, from the right, and from the left. So we get negative 2 is less than 5x, which is less than 45. And we're going to divide everything by 5. And we're going to get negative 2/5 is less than x, which is less than 9. That's your range of values for x using the Hinge theorem. All right, so any questions on any of those problems? All right, then your practice problems for today are going to be on page, you got page 375. On page 375, do 1 through 4. And then on page 376, do 10 through 15. 10 through 15, and then I want you to try to do 17 and 18.